Hi, we're Kat, Joseph, and Amelia, and we're working on detecting personal attacks in Wikipedia discussion comments. The presence of abusive language on social media has been growing, and media attention along with it. Such content has led to the proliferation of cyberbullying, hate speech, and scapegoating. Governments have begun to crack down on tech companies, imposing fines on those who don't remove abusive language in time. Due to the harmful social effects of abusive speech and financial penalties that are beginning to rise, it is becoming increasingly important to detect and remove such content. Our project aims to improve abusive content detection so that we can shift from manual to automatic detection and ultimately remove abusive content on the large scale.
For the Wikipedia dataset that we ultimately chose, previous work's shortcomings include the fact that deep learning and additional features haven't been explored extensively, and that overall performance on this dataset is low, as illustrated by the highlighted results. Our dataset, the Wikipedia Talk Personal Attacks dataset, contains over 100,000 labeled discussion comments from Wikipedia in English. Each comment contains a binary label as to whether it contains a personal attack. The majority of inputs have between 0 and 100 words, and the majority of the words in the dataset are spelled correctly. However, users posting abusive content often intentionally misspell inappropriate language to avoid detection. To help identify these instances, we used car n-grams as a feature. The goals of our project are improving accuracy in F1 scores for the abusive language detection task, and identifying structural, syntactic, and semantic features common to abusive text. Our machine learning model used a variety of features found to be significant by papers mentioned in our literature review, including the non-lexical features listed.
For our deep learning models, we represent our inputs via pre-trained glove embeddings or character embeddings, which we train ourselves. Utilizing either multiple convolution layers or LSTM layers, we generate a representation of our inputs specific for this task. We then concatenate 3 of the non-lexical features used in our machine learning model. Our machine learning model utilizes logistic regression with L2 regularization. Because LSTMs are very good for the processing sequences of information, we utilize LSTMs for one of our deep learning models. Although convolutional neural nets are more famous for image processing, the convolution operation can highlight specific features from word or character embeddings. Additionally, the parameters can be shared between different locations in the array, making more efficient use of the weights in our model. We have 3 convolutional neural net models. The first uses a fixed kernel width. The latter 2 use varying window widths to simulate n-grams of different length at the word and character level. This slide shows the results, with our varying window width CNN scoring an extremely high F1 score of 0.81, which outperforms existing literature, whose highest score is a F1 score of 0.76. The following is an example misclassification, which illustrates the difficulty of our task, as there are no particularly strong words in this example.
We hypothesized that the n-gram word CNN outperformed the other models because a small window of words can constitute a large signal in this task, for example, an abusive word. Glove representations worked especially well for this task because Wikipedia comments didn't have as many misspellings as other datasets like Twitter. And finally, features didn't help significantly as the signals may already be captured in the word vectors. In terms of future work, we hope to do an LSTM-CNN combined model, which draws upon the strengths of both models. We hope to do some hyperparameter tuning and incorporate more non-glove features before the dense layer. And finally, we hope to use attention and grid search to identify key attributes of abusive text. Thank you.